Hello, my name is Mark Ellis, and today what I'd like to do is take you through a tutorial on how to configure the Behringer X-Touch Mini, which X-KeyPad supports. What we'll cover today is installation and how to configure it, and make the buttons work and the encoders, and also to walk you through the sample for the Cessna 172 that comes with X-KeyPad for it. And then, of course, from that, you should be able to do your own configurations the way you would like them. But first, what I'd like to do is give you a little overview of this device. The X-Touch Mini is a MIDI controller, often used for, controlling music programs or video or audio editing programs. What's really great about this device is that it is pretty economical. You can get it on Amazon or Sweetwater for, I think at the price I looked at today, it was $79. So it's a relatively inexpensive hardware device. And if you take a look at it, you'll see that it's got 8 encoders. And then it's got, each encoder is an infinite encoder, which means you can keep rotating it all the way around in any direction. It doesn't have any stops on it, which makes it particularly useful for using it for flight simulation, because a lot of the rotary encoders in a cockpit, that's the way they work too. They're infinite encoders. The other nice thing about these encoders is that they've got a push button in the center of it. So that's very similar to what you see in a lot of aircraft where the rotary encoders will have a center push button on it. These are not dual rotary encoders, which means that they don't have an outer and an inner ring. They're just a single encoder. But as I'm going to show you in the configuration, it's pretty easy with X-KeyPad to configure it to emulate a dual encoder. And the way that's going to work is that a short press of the button on the encoder will toggle it back and forth between either a primary encoder or a secondary encoder, which kind of emulates that inner and outer ring that you see on a dual concentric encoder in an aircraft. And then a long press of the button, if you hold it down for maybe a quarter of a second or so, and that's configurable, then that will do a different operation in the aircraft, whether that be activating the cursor on the Garmin 530. It could be, and I'm going to show you in this example, we'll make it so that a long press on that center button will actually cause the flip-flop of a COM frequency between the standby and the active frequency. It also has, besides the buttons on the encoders, it's also got an array of 16 buttons that have got a little LED behind them that you can light up or not light based upon data within the simulator, which I'm going to show you how you do that in X-KeyPad. And then lastly, we have a slider that it's typically used in normal applications for volume control, but we can connect this up to any data ref with an X-KeyPad and give the slider a range of values, a minimum value when it's all the way down this way, or a maximum value when it's all the way up here. So in the sample I'm going to show you, we'll have that connected up to the master audio volume control in X-Plane 11, but you could connect it up to light brightness, a number of different things. And then lastly, the Behringer has 2 layers of configuration, a layer A and a layer B. And what that effectively gives you is double the number of controls on here. So where you have 8 encoders on layer A, when you go to layer B, you have another completely new set of 8 encoders. So that gives you a total of 16 encoders that you're going to work with, and a pretty wide variety of buttons that you can do. So that's the device, and I think we'll do now is we'll walk right into how you do the installation and how we do a configuration of it. It's fairly straightforward to do. Okay, so you'll see over here I've got a image of Microsoft Windows Explorer, and X-KeyPad does work on all 3 operating systems. So depending upon when you're on OS X or Linux, you use the appropriate file browser for doing this. I've downloaded the X-KeyPad 1.5 archive, which you'll be able to get when you purchase the product, or even in the free demo versions that you can get. You just download this, and now all you want to do is simply extract it. I happen to use 7-zip, but you can use whatever zip utility you want, and I'm just going to go ahead and extract this to this folder right here. Now, what you're going to want to do is you're not going to want to copy this one into the plugins folder. You're going to want to open it up. I'm going to double click on it, and then this is the one you want. And if I go one more level down, you'll see the files that are in here. So I'll come back up here. I'm going to right click on that, copy it. And then I'm going to go over to where my X-Plane 11 folder is. And I happen to have it right here. And you're going to go to Resources, Plugins, and this is where we're going to go ahead and paste it. Okay? And that's all you really need to do. You know, at this point, you know, once we get X-Plane up and running, the last thing you're going to want to do is put your registration key in. If you're just going to work with the demo version, it does work with the X-KeyPad, the X-Touch Mini, but the demo version without a registered key will limit you to the number of encoders and buttons that you can program. It's a smaller number. It's not the full set. But if you purchase a key for $15, you know, then you can you know, do the full configuration on all of the encoders and buttons on the device. So without further ado, let's go ahead and bring up X-Plane. Okay, so here we have X-Plane up and running, and just to make sure that X-KeyPad installed properly, if you come up here to the plugins menu, you should see it right here in the plugins menu. And you can also come in here and do an about.
Please check your quarantine scripts folder.
And just verify that, you know, that you can see that you've got the right version installed. Okay. Now to enter your registration key, you'd come up here to Plugins, X-KeyPad, and do the Validate Registration. And here what you would do is you would copy your key onto the clipboard, you know, from the email that you got with the key. Just paste that in right in here, and then put your email address in that you used when you purchased it, and simply do a Validate Registration, and that will get the product registered so that you can use all the full capabilities. Okay. So to start the configuration process, what you're going to want to do is come up here to the plugins menu. You're going to go to X-KeyPad, and then you want to bring up the X-Touch Mini configuration editor. And this is what it looks like. And if you've got your X-Touch device plugged in, it should show up here in the drop down, and we can just pick it, you know, like this. Now, X-KeyPad does support up to 8 X-Touch Minis if you really want to, you know, put that many on there on your system. I've actually, you know, run it with 2, giving me a lot of encoders. But for the most part, one device is going to give you an awful lot of capabilities. And particularly if you use that in combination with something like X-KeyPad with the X-Key virtual devices, gives you a lot of control over your cockpit. Okay. So what you're going to see here is that we have a drop down here letting me look at all the various encoders. And if you remember correctly, you do get 16 encoders, 8 of them on layer A and 8 of them on layer B. And the way they're numbered is the one all the way on the left is encoder 0, and it goes 0, 1, 2, 3, 4, 5, 6, 7. And then if you're on layer B, you know, it'll go 8, 9, 10, 11, 12, 13, 14, 15. So that kind of matches up, okay, what you see over here. You've also got the buttons, and the total number of buttons you've got is 50. That's because you've got 16 on the encoders, and the remainder of them are, you know, on the buttons with little LEDs behind them. So again, the way these are numbered is each encoder has its own center button on it. So that would be 0, 1, 2, 3, 4, 5, 6, 7. And then it goes 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. And obviously I had this on the wrong layer, but I was on layer B. Then it goes 24, 25, 26, 27, and so on. You get the concept of it. Okay. And then of course you've got the slider. And you have two sliders because you have one for layer A and another one for layer B. Typically with these sliders, I don't try to have them mapped to two different things on the layer A and layer B, primarily because if you switch layers and the slider is not in the exact position it should be for that other operation, it can kind of mess things up. So I typically just program the slider so it's got exactly the same definition for both layer A and layer B, which limits you to just having one function on it. But generally that's good enough, for a slider. Okay. X-KeyPad also has an ability with this little activity checkbox that as I press things on the device, it'll automatically select the right thing. And if I don't want that, I can shut this off. But let me show you. Right now, I'm on the configuration UI, I'm on the slider. But if I come over here and I rotate that encoder, it should come up here and put me on encoder 0 because that's the one that I have picked. Okay. Consequently, if I came down and I pushed, let's say the button on this encoder, it should end up picking, button 6, which is the button for that encoder. Or if I come down here and I press maybe that button, then it's going to select that button. And again, if you don't want it doing that, you can shut this checkbox off, and then as you press or operate things on the X-Touch Mini, it won't be constantly changing the configuration UI, around. Okay. So let's come back over here to encoder 0, and let's take a look at how we do a configuration on this. Okay, so let's take a look at the anatomy of an encoder. So the encoder's got a couple of modes to it. One, it could run in single encoder mode with this checkbox shut off. And what that means is you can map the encoder, the right rotation or the left rotation of the encoder, you can map it to commands, a clockwise command or a counterclockwise command. And a command is basically an operation that's in the simulator. This is typically the stuff that you map your joysticks, buttons to, or your key presses to. X-KeyPad also supports the concept of using a data ref, which is a piece of data in the simulator that you can write to. And in this case, if we use a data ref, we can specify the data ref we want, and we're going to see this in a few minutes with a few other things, and then we can give it a range that data ref can get manipulated. Say you want to manipulate the heading data ref, which we're going to do in a minute. That's going to go between 0 and 359 degrees, and then you'll be able to configure it so that what happens if you go 359, it'll wrap around to 0, or vice versa. Okay. The other thing you can do is you can operate the encoder in dual mode. And when you go in dual mode, you actually get two encoder definitions that you could do, one for the primary and one for the secondary. And the way you go back and forth between these encoders is you use the center button on the encoder to effectively toggle the encoder back and forth between the primary and the encoder. And on the button, you've got a couple of different choices on it. One, as you press the button on the encoder, it could just toggle the encoder back and forth, right? The other one you could do is a momentary swap, which means that as you hold the button down on the encoder, it'll select the secondary encoder definition. And as soon as and then you can rotate it, for that secondary encoder definition. And as soon as you let the button up, it'll flip back over to using the primary encoder definition. And then the last button operation is the long press or short toggle long press command type mode, which is frankly very, very commonly used. And in this is the case where a short press on the button is going to toggle the encoder back and forth between the primary and the secondary definition, and a long press would actually get associated with a command. That you might want to operate when you hold the button down for a quarter of a second or so, whatever you program that to. Okay, so in this example, let's configure this encoder so that what it will do is adjust the COM frequencies for COM1. Okay, so the first thing we're going to want to do is figure out what are the commands that we want to do. So we're going to run it in dual mode. Okay. And what commands do we need to operate when I go clockwise or counterclockwise? So down here we have these little finders. that will help you find the commands, okay, that you need. And I know that we're doing COM1, and COM1 is in the name somewheres. So if we come down here and we take a look at this, we'll see that we've got the COM1 standby frequency for the 833 kilohertz spacing, which is typically what we want to do, is we have coarse up and coarse down, and then we've got fine up and fine down, okay? And we're going to configure these to the various operations. So the first thing we'll do is we'll take, let's take the coarse up. What I'm going to do is I'm going to copy that, and that's going to be probably the clockwise mode. We'll paste that there. And then we're going to find the coarse down. We'll copy that to the clipboard, and we'll paste that there. Now I just messed up. I actually put that on the secondary encoder. It probably doesn't really matter that much because you can't tell, you know, which mode you're in. So we'll put that one on the secondary encoder, and then on the primary encoder, we're going to do the fine. So we'll go fine up, copy this, we'll put that in the clockwise direction, and the fine down, we'll copy that to the clipboard, and we're going to paste that there. Okay. Now the next thing we're going to want to do is when we do a long press on that button, we want that to actually do a swap between the standby frequency and the active frequency. And I believe if we come up here and look, here it is, COM1 standby flip. Okay, so we're going to copy that, and over here in the long mode, we're going to copy and paste that command right in there to do the standby flip. And then we'll also give the encoder a name. We'll call this COM1 standby. Okay, let's save that. And why don't we go on up and let's get the plane fired up and take a look how it works. Okay, so if we did this right, as I rotate this encoder to the right, we should be increasing the coarse frequency on COM1. If I rotate it to the left, it should be decreasing it. And then if I give the button a short press, it should now switch me over to increasing the fine frequency. Turn to the left, it should decrease it, and then if I hold it down, it should do a swap. So that's how easy it is to configure in an encoder to do what you want it to do. Okay? Now let's take a look at another example of one we might want to do. Let's say, I guess the heading is another good one that we might want to have. So let's close this. Actually going to pause that so we don't have to listen to that noise from the plane. And let's go over here and let's say we're going to take this encoder here and we're going to set this one up so that it works with it manipulates the heading bug. Okay? So in this case, we can use the commands that let you move the heading bug up and down. And that actually works pretty good. But here's one of the challenges with using commands for things that you actually might want to spin fairly quickly. So on the heading bug, you might want to really turn that encoder at a pretty good rate so that the heading bug moves rather rapidly. One of the problems with using an encoder in commands like that is that the commands have to get queued up. You know, with each turn of the encoder, a slow click is going to give you the command once. If you turn the encoder fast, the X-Touch Mini is actually able to send X-KeyPad an indicator that you turned it a few slots. But no matter how we do it, X-KeyPad has to actually queue the commands up to move that heading bug that many increments using the commands. And what can happen is it can get behind a little bit and get a little sluggish, right? So if you turn really quickly, it may take it, you know, a half a second or a full second for the heading bug to actually move the full distance. Another way to do this is to use a data ref. Now we're lucky in the sense that the X-Plane has a writable data ref underneath the covers that represents the position of that heading bug. And it's a simple integer value that moves between the value of 0 to 359 degrees. So we can actually configure X-KeyPad so that as you rotate that encoder, it's going to directly manipulate the value of that heading bug. And what makes this really great is if you turn the encoder really fast, X-KeyPad's going to see that you turned it, 4, 5, or 6 increments. And rather than trying to send 6 commands to X-KeyPad to increment that heading bug around, it's simply going to turn around and look at the data ref and go, okay, I need to add 6 to that. And if that happens to push it, over the 360 degree mark, then I'll simply do the calculation to figure out, like if I was at 358 degrees and I moved at 6, I need to know that that's going to be 004 degrees in the heading. So it's pretty smart in the way that it works. Okay, so let's take a look at how we do that. So in that case, we're going to come on over here. We're going to look for data refs. And we are going to put this encoder so that it uses data ref mode. And for the moment, I'm going to just use this as a single encoder. So we'll call this heading. And down here, let's see if we can find the data ref for the heading bug. Ah, it's right here. SimCockpit Autopilot heading. Okay. And we're just going to grab this here, and we're going to paste that in for the numeric data ref. Now we have a couple of ways to operate this. Infinite means that as I keep turning this thing, what it's going to do is it's going to keep incrementing the thing up and all the way down. What I'm going to want to do is actually work this in a wrap mode, okay, where the increment amount is going to be 1 degree, the minimum value is 0, and the maximum value is 359, okay? And if we actually come in here and zoom in a little bit, let's see if we can't get a closer view of what's going on here. We'll temporarily put that down. And as I turn this knob, you can see that the heading bug goes. And you can see it's very responsive. So if I turn it quickly, it moves really fast, right? Another thing I could do with this is, let's bring this back up here again and run that encoder. What I can do is I can now program the center button on that to say, maybe when I push that heading bug encoder button, what I might want to do is have it do a heading sync, which basically will synchronize the heading bug to your current magnetic heading. So to get that button, I'm just going to push this. And sure enough, it's button number 1. I'll call this heading sync. I'm going to look for a command down here. I think it's called sync. Let's see. Autopilot heading sync. I'm pretty sure this is it right here. And we can actually try this in here. Let me see if I can't make this a little bit smaller. So if I try it, you notice right here the heading bug is at, what is that, like 140 degrees. If this does what I think it should do, if I try it, sure enough, see it jams it right up to whatever my current magnetic heading is. So what I'm going to do is I'm going to copy that. I'm going to paste it in. And if it's working right, as I turn this and I push the button, it's going to sync it. Okay. So I think that shows you the various ways that you can program an encoder. And in a minute, we're going to show you how you can actually manipulate the ringlets on the encoder too, but I'll do that with a sample that we've done. Okay, let's take a look at maybe doing one of these LED lit buttons. So let's take this one here. Okay. That's button number 8. That's this one here that I'm pointing to. It's got the little clear keycap and it's got a yellow LED underneath it. Let's program this one so that it manipulates let's say that maybe the taxi light. Now here's another interesting thing we can do. There is an option on here in the finders to say show last active command. So I either can come in here and I can try to find it. So there's the various commands associated with the taxi light. There's a taxi light off, taxi light on, and taxi light toggle. And if I actually come up here and operate the taxi light, which if I turn that on, you could see that what it's doing is it's using the on and off command. Okay. Now in my case, I think makes it easier is I think I just want to use the toggle. So if I try it here, you can see that that's going to toggle that back and forth. So I'm going to copy that. I'm going to come up and I'm going to paste it. And then if it's working properly, as I push this button, sure enough, it toggles the taxi lights on and off. Okay. Now that's cool. But what would even be cooler is if I can light the LED underneath that button so that it is lit when the taxi light's on. So for that, let's make this a little bit bigger. For that, we're going to want to use a data ref, okay? And if we come down here to LED operation, what I can do is associate a data ref with the LED, okay? So the first thing we'll do is let's see if we can find the one we need. We'll search for taxi. This looks like it. Sim cockpit electrical taxi light on. You can see that its current value is a 1. And let me actually operate that and see if it goes back and forth. Yes, so as you can see, as I push the button, it goes from a 0 to a 1. 1, you know, when the light's on. So what I'm going to want to do is copy that data ref. I'm going to paste it in here. And now I have a couple of choices. This area down here is called the logic test. And what you're going to do is define what's the expression you're going to use when you want to evaluate that the LED should be on. And then you could have another expression that it will evaluate you know, when you want the LED maybe to blink. And if neither one of those tests true, then what's going to happen is the LED is going to be off. So for our case, we're not interested in the blink, okay? And I could probably actually make it so that we can show you how you could make it do a blink. But let's say for a moment, I want the LED on when the taxi light's on, and I want it off when it's off. So here, we're going to come in here, we're going to say the logical test is equal to a 1. And in this case, we're not going to really put anything in here. If I do an AND with nothing in there, this will always evaluate to false. So if this is working right, as I click the button, you're going to see that the LED test is turning true when the light's on. And sure enough, if you look at the X-Touch Mini, the LED lights on and off. Okay, let's say as an example, maybe I want it to be when it's off, I want the thing to blink. Well, that's pretty easy. We would just come in here and we would do an equal, and we say if it's a 0, then it's going to blink. And if you look at the X-Touch Mini, sure enough, the light's blinking when it's off, and it's solid on when the light's on. Okay? So that's the kind of stuff that you can do with this. And frankly, there's even a capability up here to use an expression, which we're going to actually show in another example down the road, where you can actually combine multiple data refs together mathematically to come up with a value that you can then test as to whether these LEDs should be on or off. So you can get pretty sophisticated with what you can do here. Okay? We'll just do a save to save that configuration. So now you've seen how you can program the encoders and how you can program the little buttons with the LEDs underneath them. Okay? Now, what probably makes sense at this point is I'm going to go in and I'm going to load a sample that comes with X-KeyPad for the Cessna 172, and that one will actually show us a whole lot of capabilities. Okay, so to bring in the sample, I'm just going to come up and do an import. I want to go to Resources, Plugins, X-KeyPad, Samples, X-Touch Mini, and the one we want is this X-Touch 0, which is Unit 0 for the X-Touch Mini, and I'm going to click on that and I'm going to bring this in. And this now loads that, that pretty full-blown configuration, okay, that we've got. All right, so let's take a look at some of the things that we've got in here and what we can do with it. So let's take a look at the sliders. So I've got the slider configured to control the audio volume, you know, in X-Plane. So what this allows you to do is as you're moving the slider up and down, the volume control for the sounds that you're hearing within the aircraft, okay, will go up and down. Now, a slider is interesting. You really can't associate it with a command. It has to be associated, you know, with a data ref, okay. And in my case, it's pretty simple. This is the data ref for the master volume, and it's a ratio. It's simply a value between 0 and 1.0. 0 being no volume, 1.0 being maximum volume. So all you have to do is come in here and put in what's the minimum and the maximum value that you want for when that slider's all the way down or all the way up. And if you look, as I move the slider down, you can see the current value goes to 0. If I move it all the way up, it goes to 1.0. And I can reverse this. If I want the slider to work the other way around, you know, now when it's all the way down, it's at its maximum level. And when it's all the way up, it's at its minimum level. So you can, you know, kind of make it work the way you want it to work. And let's just see if this works. So you can see. So you get a sense of how that works, okay? And, you know, the slider's great for things like the volume and the plane. It's also, you could use it for things like your panel lighting, for how bright you want your panel lights at night to be. You could even configure it so that it operates your flaps. You know, there's a flap ratio data ref that you can put in here. Even your elevator trim, you know, could get used, you know, on this. So lots of capabilities, you know, for what you could use the slider for. The one disadvantage of the slider, though, is I would recommend you always associate it with the same function for both layer A and layer B. And the reason being is that if you move the slider while you're on layer A, if you go to layer B and it's mapped to a completely different operation, that slider position that you had it in for layer A is not going to match up where you had it in layer B. You know, and it's immediately going to change that data ref to the new slider position, and that may not be at all what you want it to do. You know, typical example where this can get messed up is if on layer A you've got it on flaps, and on layer B you've got it on something like your elevator trim. As you go back and forth between layer A and layer B, your flaps and your trim positions are going to radically change. You know, based upon where the slider was in the opposite position. So typically it doesn't work all that great using the slider and having two functions on it, one for layer A and one for layer B. Okay, let's take a look at another thing we can do here, which I think is kind of interesting. On layer B, yes. On layer, let's actually look at this one here. This is probably a better one. Panel brightness. I want to show you this. So the panel brightness is controlling the instrument lighting and the Garmin 530 lighting, okay? And you can see here that in this configuration, I'm actually using a master data ref, and I am using some slave data refs. And the reason for this is that in X-Plane, there's actually a number of different data refs for the various instruments. You know, some are for the steam gauge instruments. Some of them are for the Garmin 530, you know, panel lighting. and some are for like the pedestal lighting, okay? And typically they're all in this one data ref called instrument brightness ratio, but that data ref is actually an array. Okay, it's got multiple indexes and entries into it. It's actually an array of 32 different positions. And you kind of have to poke around and figure out which array index is associated with which control within the 3D cockpit, for controlling the panel brightness. But in my case, I've already gone out and I figured it out that they're at index 0, 2, and 1. And I just happen to pick 1 as being the master. So what I've done here is, and what I'm going to do is when I change that encoder, it's going to actually change all of these to be the same value. So the way these brightness ratios work, they go from a range of 0 to 1.0, 1.0 being the brightest. Here, because it's an array, you have to pick the index you want. And in my case, I'm going to use it as a limits. So limits means that if I turn the encoder to the right, it's going to kind of keep incrementing it by this increment value of, I got it set to 0.01, and it'll keep incrementing it until it reaches the maximum value of 1.0, and then at that point, turning it to the right, it's not going to do anymore. Actually, see if we can make it do that. Yeah, so as you see, if I turn it, it goes all the way up to 1. If I turn it this way, it goes all the way down to 0. Okay? And slave data refs, the way they work is whenever I change the master, I'm automatically going to update the slaves to exactly the same value. So in this case, I'm actually controlling the panel brightness for a number of different panels within the aircraft, the steam gauges, the Garmin 530. Let's see if we can actually see that here. Let's go to pilot view. Let me close this. I think I've got something here that does time of day. Yeah, I have one encoder here that I've got programmed so that we can make it really dark. And then if I manipulate these panel brightness things, you can see they're lighting not only the steam gauges, but also the Garmin 530. And I've actually taken this other encoder and it's actually set to the brightness of the glare shield. There's some lights on the under part of the glare shield for the Cessna 172. So I think that gives you kind of an idea of the type of thing that you can do, with this. So let's see if we can actually make it back to daytime levels here. Okay, so that's showing you all the different things you can do with encoders. The one thing left that I want to show you is how to do the ringlets. So these encoders have got little red LEDs around them. And how you program them depends on the pattern that you want in them. And actually, if you give me a minute here, let me bring up the user guide, and I'll show you the tables in the user guide that show you what these values are for the ringlets. So they're in the appendix. And I guess this is probably good. Hopefully you can see this. So there's a couple of modes that these ringlets work in: fan mode, trim mode, and spread mode. And the values that you have to put into the X-Touch Mini to make the LEDs light up, they vary based upon the mode that you want to operate in. So values between 32 and 43 give you fan mode. So with 32, none of the red LEDs are going to be lit. With 33, the one all the way to the left, and then you could see it kind of increments up in like a fan, okay? Then you could do this trim mode, which makes it look kind of like an hourglass, so that when the encoder is sort of in its middle position, just the middle LED will be lit. And then you could do it in a spread mode. Now, you might ask, why are these like this? A lot of it's got to do with the fact that the X-Touch Mini was originally designed to work as an audio controller, or it's very commonly used, for editing videos, where you might want to trim a clip, or you might want to change the volume on a clip. So that's why these LEDs have these various modes. But at any rate, what we've got to do is we've got to set a value here based upon what the maybe the underlying data ref's value is representing. So let's go back over to our panel brightness. Our panel brightness encoder, which I think is this one right here. Okay. Now what you could do is you can use the ringlet expression to calculate what that value is going to be. Okay. Now in the ringlet, the way expressions work, and there's a much longer discussion on expressions in some of the other tutorials for X-KeyPad, but expressions give you a way of combining multiple data refs, which we'll associate with a variable name, with a mathematical expression to come up with a new value. Okay. And this ringlet expression is rather unique, where the output of that mathematical expression, it's going to get jammed into that ringlet value that I just showed you in that table, so that we can control how we want those LEDs to light up. So in our case, for the panel brightness, I'm going to have a variable here which I'm going to refer to as the ratio, and you can see that that's basically looking at that panel brightness ratio index number 1, which was our master data ref for controlling the panel brightness. Okay, and then if I collapse this, let's take a look at the mathematical expression. What the mathematical expression says is take the current ratio. If you remember correctly, that goes between a value of 0 to 1.0. We're going to multiply that times 11, because there are actually 11 LED positions, right? If you remember the table, they start off at 32, which is none of the LEDs lit, and then 33, 34, 35, 36 will consecutively light LEDs around the ring, starting in a clockwise fashion. So here we're simply mathematically multiplying the ratio times the 11. So in other words, if I got the panel brightness up to a full bright, which would be 1.0, that's going to basically give me an 11 that we're going to add to 32. If the ratio is all the way down to 0, which is no panel brightness, 0 times 11 gives me 0, and we're going to end up with 32. And you can see down here we get the result. So as I turn this encoder, you'll actually see this result value down here changing. And if this is working right, you should be able to see the ring LEDs on the encoder going up and down. Okay? So that's how that works. And I think the only other thing I want to show you here is one of the challenges with the X-Touch Mini that I've seen is labeling it. Now, it's not a problem, too bad, if what you're going to do is have one configuration on an X-Touch Mini that's going to work for every aircraft you fly. That, frankly, is sometimes a little hard to do if you fly a lot of different planes, because what you might want to use encoders for, it may vary from aircraft to aircraft. Not commonly, you'll get the common ones like the comm frequencies, the heading bug, but you may find in some aircraft that you want encoders for some functions, and in other aircraft you want them for other functions. So labeling this this device can get to be kind of a pain in the neck. You could try to do like an overlay that you print out and cut out, where the encoder holes are and the buttons holes are, and then you change that template over the top of it every time you switch planes, or something like that. Another concept is to use the virtual device capabilities with X-KeyPad to create effectively it's an electronic legend for the device that can be very dynamic. And what I do is I have a small monitor, relatively inexpensive, small USB monitor, or even going to be a small HDMI monitor that I can place behind my X-Touch Mini. And then I can have this legend show up that shows me what those keys are. So I've actually done one of these for the Cessna 172 sample that we can actually bring in and take a look at it and see how it works. So let's close this. And what I'm going to do now is I'm going to bring up the X-KeyPad configuration editor. Now this is the editor that allows you to create virtual devices, which are pop-up windows that have got programmable grid layout keys on them. Okay, so I'm going to come up here and I'm going to do an append. And again, under resources, plugins, X-KeyPad, samples, X-Touch Mini, you'll see that I've got an X-Key Cessna 172.json file, which is this little legend virtual device that I've created. And here it is. So what you could do with this is you can resize it to what you want. And then you can put it, let me just close this here. We'll save that, close it. And now what you could do with this is you can take it and you could put it on that spare monitor and put it right behind the X-Touch. And if we work with it here, you can see that as I change the layer, this is going to change back and forth. I've made it so it's very dynamic. It actually does things like, it'll follow the operation. So here I'm toggling the beacon light on and off. So not only do you get the LED under the button on the X-Touch changing, but it also changes, on this little legend device. And also true with the comm frequencies, right? That as I change this, you'll see on comm 1, it's changing. Same with the heading, which I think I did over here. Okay. So that's another thing, that you may find pretty useful. And these things do take a little bit of effort to configure. There's a whole another set of tutorials on how to use the X-Keys virtual devices. But you might find that doing something like this is pretty helpful for you, so that your legend can be very dynamic. If you do a completely different configuration for a different plane, when you load that plane, a whole new one of these will come up, and it would be very easy for you to tell what encoders do what. Okay, so I think that pretty much covers everything I wanted to cover on the X-Touch Mini. A couple of things I only glossed over: the expressions. They actually are very powerful, and they could be used in a number of different ways. But if you look at the tutorials for the X-Keys configuration editor, we actually have a whole tutorial that's going to be done on formulas and expressions that will actually bring you into a greater in-depth understanding of how you can use those. So thank you very much. I appreciate your listening. I hope that you enjoy using X-KeyPad with an X-Touch Mini.